Hello friend, do you know why any organic or inorganic molecule have their own particular geometry or shape? For example, carbon dioxide has linear geometry or shape, while methane molecule CH4 molecule has tetrahedral geometry or tetrahedral shape. Why it is different for different organic molecules? The reason is hybridization. Here we will discuss what is hybridization and its different types like Sp3, Sp2, Sp hybridization in easiest way. After that we will see how to identify the hybridization state of any atom in given structure. I will give you one trick. By using that trick you can find or identify the hybridization state of any atom in given structure within a 2 seconds only. So let's start the video. The hybridization is the mixing of orbitals. There are four types of orbital: S orbital, which is spherical in shape; P orbital, which is dumbbell shape having equal lobe, two equal lobes; and D orbital and F orbital. So hybridization is the mixing of two or more pure orbital. Here S orbital is pure orbital, P is pure orbital, and after mixing of these two pure orbital we get the Sp hybridized orbital. We get a new set of equivalent orbitals. After mixing of pure orbitals we will get two set of new equivalent orbital, and that new equivalent orbital is called hybridized orbital. This hybridized orbital has the similar shape. You can see here these two hybridized orbital has the similar shape. They also have the equal energy, but they are different in their orientation. So here S and P orbital are pure two orbitals. They are mixed together to give the two equivalent hybridized orbital. It has a similar shape and equal energy, but they have different orientation in space. If we mix two orbital, then we will get two hybridized orbital. If we mix three orbital, then we will get three hybridized orbital. So number of orbital we are mixing is equivalent to the number of hybridized orbital will form. The hybridized orbital has different orientation in space, and because of this different orientation every molecule has their own particular geometry. Because of difference in orientation of the hybridized orbital, molecule exist in their own particular geometry. So hybridization is responsible for the geometry or shape of the molecule. You can see here this is the px orbital, this is py orbital, and this is pz orbital. They have the same shape, equal energy, but they are differ in orientation. Here you can see x is on horizontal line, z on vertical line, and y on this line. So their orientation is different and it results in different geometry of different molecule. So coming to the hybridization, Sp3 hybridization. There are three types of hybridization. One is Sp3, then Sp2 and Sp3. We will discuss one by one. Here we take the example of carbon. The carbon atom has 6 electrons, and according to the above principle of electronic configuration, the ground state configuration of carbon is like this. In 2 electron is in 1s orbital, 2 electron in 2s orbital, and remaining 2 electron is in 2p orbital. One is in px orbital, second one in py orbital. While it has a carbon has only 6 orbital, 6 electrons, so 6 electron is placed in orbital like this, and pz orbitals remains empty. When carbon is comes in contact with other atom or molecule to form a new molecule, then this one electron from the 2s orbital takes the energy from environment in the form of light or heat or any other way and get excited into pz orbital. This 2s orbital is lower energy state while pz orbital is at higher energy state. So this one electron from 2s orbital get excited into pz orbital, and excited state electronic configuration of carbon is looks like this. Now this is the sp3 hybridization. So in sp3 you can see here single s and 3p. So one s orbital is mixed with 3p orbital. So mixing of this one orbital with the three orbital gives four equivalent set. It gives the equivalent set of four sp3 hybridized orbital. They have equal energy. You can see here. This is the vertical line or y-axis showing energy level. So here is the lower energy, here is the higher energy. If you see here, the 2s is present at a lower energy than 2p. So the newly formed hybridized orbital is present intermediate to both this orbital, but they all this for sp3 hybridized orbital has the equal energy. So by mixing of 1s orbital with 3p orbital px, py, pz gives rise to 4 equivalent sp3 hybridized orbital. They have equal energy, similar shape, but differ in orientation in space. This is the carbon atom, and this 4 is sp3 hybridized orbital. They have similar shape, equal energy, but differ in orientation. You can see here, one is here, one is here, and other two is here. If we see the 3D structure, then 3D structure of methane molecule, then you can see here sp3 hybridized orbital of the carbon is oriented toward the corner of tetrahedral. So any molecule which having sp3 hybridization state, it shows the tetrahedral geometry. Suppose here carbon is exist in sp3 hybridized state, so its geometry or its shape will be tetrahedral, and the bond angle is 109.5 degree. If we measure the bond angle between CH bond and this CH bond, then it will be 109.5 degree. If we measure this angle between these two bond, the bond angle between these two bond, it also 109.5 degree. The bond length between this carbon and hydrogen bond is 1.09 angstrom. So if the molecule is exist in or atom in molecule is exist in sp3 hybridized state, then bond angle of that molecule is 109.5 degree and shape will be tetrahedral. Coming to the sp2 hybridization, here carbon atom, it has the similar ground state configuration. This one electron from the 2s orbital get excited into pz orbital, then excited state electronic configuration of carbon is looks like this. But here hybridization type is sp2 hybridization, so one s orbital will mix with 2p orbital only. In case of sp3, what happen? One s orbital is mixed with 3p orbital. So in sp2 hybridization, one s orbital is going to mix with 2p orbital only. So this one s orbital mix with this 2p orbital only. So px, py and s orbital mix and form the equal set of equivalent orbital, that is sp2 hybridized orbital. We are mixing three orbital here. One is s orbital, second is px and third is py. So three orbital are mixing, so we get the three equivalent sp2 hybridized orbital having same energy, similar shape, but orientation will be different, and the pz orbital is remains unhybridized. So here one orbital, that is pz orbital, is remains unhybridized. So if you see this structure, this is the carbon atom and this is 3 sp2 hybridized orbital of that carbon, and this one is pz pure unhybridized pz orbital. This pz orbital is unhybridized, so it is showing two equal lobe. If we combine two carbon atom with sp2 hybridization state, then this sp2 hybridized orbital of first carbon is overlap with sp2 hybridized orbital of second carbon and form the sigma bond. This sigma bond is due to the overlapping of sp2 hybridized orbital of both the carbon atom. This is again sp2 hybridized orbital of the carbon and it is overlapping with s orbital of hydrogen and form carbon hydrogen CH bond, sigma bond. This is also sigma bond formed by overlapping of sp2 hybridized orbital of carbon and s orbital of the hydrogen. Similar here, two sigma bond is formed with hydrogen, but both these carbon have the unhybridized p orbital. So the unhybridized p orbital of first carbon overlaps with unhybridized pz orbital of second carbon and forms the bond called pi bond. So remember here, sp2 hybridized orbital of both the carbon form sigma bond, while unhybridized orbital is responsible for formation of pi bond. In simple, here is first carbon, this is second carbon. This bond is sigma bond formed by overlapping of sp2 hybridized orbital of both the carbon. This hydrogen carbon hydrogen bond is formed by overlapping of sp2 hybridized orbital of carbon with s orbital of the hydrogen. Similar here, ch bond is formed by the overlapping of pure s orbital of hydrogen and hybridized sp2 orbital of the carbon. Similar here also, but both the carbon have pz unhybridized orbital, and the overlapping of this pz orbital forms the pi electron cloud near this sigma bond, and that is it is forming the pi bond. The bond angle is 120 degree. The molecule which having atom with sp2 hybridized state, it's showing the bond angle of 120. If we measure bond angle, this bond angle, it is also 120. If we measure this, it is also 120. Similar here, it is also 120, 120 and 120. The bond length between bond length of the carbon carbon double bond is 134 picometer, while bond length of carbon hydrogen bond is 110 picometer. So in sp2 hybridized molecule, the shape of molecule or geometry of molecule is triangular or trigonal shape. The any molecule which having atom with sp2 hybridization state, then it will show triangular or trigonal shape. Coming to the sp hybridization, here also this is the ground state configuration of electronic configuration of carbon. If this electron is get excited into the pz orbital, then excited state electronic configuration is look like this. This is the sp hybridization. So one s orbital and one p orbital is going to mix. So this one x orbital is mixed with one p orbital, that is px orbital, and by mixing of these two orbital we get the two equal sp hybridized orbital, and remaining two p orbital, that is py orbital and pz orbital, is remains unhybridized. If we see here, this is the carbon and this is the two sp hybridized orbital of the carbon. This is first sp hybridized orbital, this is second sp hybridized orbital of this carbon, and this py is the unhybridized orbital and this pz is the unhybridized orbital. If we combine this sp hybridized two carbon atoms, then we results in formation of sigma bond between two carbon by overlapping of one sp hybridized orbital of one carbon with sp hybridized orbital of second carbon. This sp hybridized orbital of first carbon overlap with sp hybridized orbital of second carbon and form sigma bond, while another sp hybridized orbital of one carbon overlap with s orbital of hydrogen and form carbon hydrogen sigma bond. Similar here also, but here each carbon has two unhybridized orbital or two unhybridized p orbital. One is py, this is py, and another is pz, this is pz. So the py unhybridized orbital of first carbon overlap with unhybridized py orbital of second carbon and form the first pi bond. And similar to this, pz orbital of first carbon, it is unhybridized state, and pz unhybridized orbital of another carbon forms second pi bond. So total two pi bond and one sigma bond is formed. This sigma bond is due to the overlapping between sp hybridized orbital, while pi bond is due to the overlapping between unhybridized orbital. Simply here, this sigma bond is due to the overlapping of sp hybridized orbital. This hydrogen carbon hydrogen bond is also due to the overlapping of sp hybridized orbital of carbon with s orbital of hydrogen, while this py is unhybridized of one carbon overlap with py unhybridized orbital of second carbon and forms the bond called pi bond. Similar to pz is also unhybridized orbital, it also overlap and forms second pi bond. So here triple bond is present between two carbon, in that one bond is sigma bond while two bond is pi bond. The bond angle is 180 degree. If we measure the bond angle here, it is also 180, it is also 180. So the bond length between carbon carbon triple bond is 120 picometer, while bond length of carbon hydrogen bond is 108 picometer. The shape of the molecule is linear shape. The molecule which having atom with sp hybridized state, it shows the linear shape. you can see this molecule, it is linear shape or having linear geometry. In summary, the sp3 hybridization is results from mixing of one s orbital and 3 p orbital to give the new equivalent set of 4 sp3 hybridized orbital. The sp3 hybridized molecule is showing tetrahedral geometry with bond angle of 109.5 degree, while in sp2 hybridization one s orbital is mixed with 2p orbital to give the set of new equivalent sp2 hybridized orbital. We get the 3 sp2 hybridized orbitals and one pz orbital is remains unhybridized. The shape of the molecule or geometry is a trigonal planar or trigonal or triangular shape, and bond angle is 120 degree. In case of sp hybridization, one s orbital is mixed with one p orbital to form the two new equivalent set of sp hybridized orbital, and two p orbitals are remains unhybridized state. One is py and second one is pz unhybridized orbital. The shape of the molecule or geometry is linear and bond angle is 180 degree. In case of sp hybridization, it shows the 50% s character and 50% p character, because it has the two orbital which is going to mix, one is s and one is p. So two orbital are there, and so if we divide 100 into two parts, then 50-50, so 50% is s character and 50% is p character. In case of sp2 hybridization, it is the mixing of one s orbital and two p orbitals, so total is 3 orbital. If we divide 100 or into 3 parts, then the one part, that is s 33.33% is s character, and remaining 66.66% is p character. In case of sp3 hybridization, it has the one s orbital and 3 p orbitals, so total 4 orbital. If we divide 100 into 4 part, then s character will be 20% and p character will be 75%. So what we learn till is the what is hybridization and its different types. Now we will see how to identify the hybridization state of any atom in given structure. For example, if we have the structure of this ethane and we have to find out the hybridization state of this carbon atom, then how to find out hybridization state, or how to identify in which hybridization state this carbon is exist. So we have to count the charge center or sigma bond formed by this carbon atom. If we know how many sigma bond or how many charge center with to which, or how many sigma bond or how many charge center is associated with this carbon atom, then by using this trick we can find out hybridization state of that atom. So if it has the two charge center, then it is sp hybridized state. If it has three charge center, then sp2 hybridized state. If it has the four charge center or four sigma bond, then it will have sp3 hybridized state. So if two charge center means here one is s orbital, one is p orbital, so total orbital is 2, so it is two charge center. Then in case of sp2, it has one s orbital and two p orbital, so total orbital is 3 and 3 is equivalent to 3 charge center. Likewise, you can remember this trick. If it has the 4 charge center, it means 1 is s orbital and 3 p orbital, so total orbital is 4. So 4 charge center means, so 4 charge center means sp3 hybridized state. So in case of ethane molecule, this carbon atom has 1, 2, 3, and 4 charge center or 4 sigma bond. So it is equivalent to sp3 hybridized state. So this carbon is existing sp3 hybridized state. In case of ammonia, nitrogen has a 1, 2, 3, and this lone pair is counted as a fourth charge center. So 4 charge center is equivalent to sp3 hybridization, and this nitrogen is existing sp3 hybridized state. In case of NH4 plus molecule, nitrogen has 4 charge center or 4 sigma bond, so its hybridization state is sp3 hybridized state. In case of water molecule, oxygen atom has, this is first, this is second, this lone pair is third, and this lone pair is fourth charge center. So oxygen is also exist in sp3 hybridized state. Here this carbon has 4 sigma bond or 4 charge center, so its hybridization state is sp3. But this carbon has 3 charge center, one is here, second is here, and third is here. This double bond is counted as a 1 charge center, so total 3 charge center. Or if we count sigma bonds, then this carbon has, this is first, this is second, and here 1 sigma bond, so total sigma bond is also 3 sigma bond. Because in double bond, one bond is pi bond and another bond is sigma bond, so this have only 3 sigma bond or 3 charge center, so its hybridization state will be sp2 hybridized state. Similar to this carbon, this carbon is also have 2 charge center or 2 sigma bond, one is here and second is here, so it exists in sp hybridized state. In case of this alkene or alkyne, it has a 2 charge center, this is first and this is second, or it has 2 sigma bond, this is first and this is triple bond, here 2 bond is pi bond and 1 bond is sigma bond, so this is second sigma bond. Total sigma bond is 2, total charge center is 2, so this carbon is existing sp hybridized state. Similar here, this carbon also have 2 charge center or 2 sigma bond, so it exists in sp hybridized state. Here this carbon has 3 charge center or 3 sigma bond, so it exists in sp2 hybridized state. In case of carbon dioxide molecule, carbon is existing sp hybridized state because it has the 2 charge center, one is here, one is here, or if we count the sigma bond, then here 1 sigma bond, here 1 sigma bond, total 2 sigma bond equivalent to sp hybridized state. Oxygen atom in carbon dioxide has, this is first, this is second, this is third charge center, so 3 charge center equivalent to sp2 hybridized state of oxygen in carbon dioxide. This is the structure of carbon dioxide. You can see here oxygen exists in sp2 hybridized state while carbon exists in sp hybridized state. If we see the structure of methyl carbanion ion, it has the 3 sigma bond and 1 lone pair of electron, which is counted as a fourth charge center. So total 4 charge center equivalent to sp3 hybridized state. In case of methyl carbocation, this positive sign is not counted as a charge center, so only 3 sigma bond or 3 charge center is exist with this carbon atom. So methyl carbocation has the carbon atom with sp2 hybridized state. In case of methyl free radical, it has the 3 charge center or 3 sigma bond and 1 unpaired electron. It is not counted as a fourth charge center, So only 3 charge center are exist, and this carbon atom of the free radical exists in Sp2 hybridized state. In case of NO2 plus molecule, nitrogen has the two charge center or two sigma bonds, so its hybridization state is Sp hybridized state. In case of NO3 minus molecule, nitrogen has the three charge center, and so it exists in Sp2 hybridized state. In case of NH4 plus molecule, it has the 4 sigma bond and 4 charge center, so its hybridization state will be Sp3 hybridized state. In case of SO2 sulfur dioxide molecule, sulfur atom has the 1, this is second, and this lone pair is third charge center, so total 3 charge center equivalent to Sp2 hybridized state. So in SO2 molecule, yes, sulfur is existing, yes, Sp2 hybridized state. In case of SO3 molecule, sulfur trioxide, sulfur also has the 3 charge center and it exists in Sp2 hybridized state. Similar to sulfur, this sulfur, oxygen also has the 3 charge center. This is first, this lone pair is second, this lone pair is third. So total 3 charge center, and hybridization state of oxygen is also Sp2 hybridized state. In SO3 2 minus molecule, sulfur atom has this is first, this is second, this is third, and this lone pair is fourth charge center. So total 4 charge center equivalent to Sp3 hybridized state of this sulfur atom. In case of SCl4, the sulfur atom has the 4 bond or 4 charge center here, and this lone pair is fifth charge center. So total 5 charge center, and it is equivalent to Sp3 dehybridized state. Similar in SCl4, sulfur has the 6 charge center exist in Sp3 d2 hybridized state. Here also sulfur has the 4 charge center, 2 is bond and 2 is 2 lone pair of electrons, so total 4 charge center equivalent to Sp3 hybridized state. Similar to this, you can find out the hybridization state of phosphorus atom also. Trick is same. I hope this video will helpful for you. Thank you.